Let's please start, otherwise we'll never finish in time. Okay, so welcome to this presentation. Jorge, well, you know
Jorge Timón. Yeah.
Jorge Timón will start.
Can you hear me? Yeah. So I'm Jorge Timón. I've been working on things related to complementary currencies and blockchains for a while on my own, on my free time, and now I'm working for Blockstream on the same. Which is a company, we do cryptography, security, blockchains. But what are these blockchains anyway, right? Some people say that they're going to fix everything, and I don't think so. But I think they can solve a lot of interesting problems. One of them being complementary currencies, which don't really need them strictly, but they can work better or have more functionality using blockchains. So the first blockchain was Bitcoin, which is also the first peer-to-peer currency. And it uses a chain of blocks. It's a chain because they go one after another. And the blocks include transactions. And it also uses digital signatures so that only the owners, the current owners of the funds, can authorize to move them. The most interesting thing about blockchains, or what I think is most interesting, is that they work with a set of consensus rules that all users can validate. They get the blockchain from peers, and they validate all the rules. For this to work, it needs to be developed as free software, because or at least open source. Because otherwise, the program could do something else, or not validate these rules, do something else. So if somebody tries to sell you a blockchain as non-free software, I would say stop listening, because it makes no sense not being free software. So this auditability allows Bitcoin to require very little trust. In fact, Bitcoin is a little bit extreme in how little trust it requires. It also has scripts which serve to create smart contracts, and this allows us to extend the system in ways we didn't thought about at first, but since scripts are generic, you can invent new things without having to change the consensus rules. And also the scripts allow smart contracts. Some of them allow interoperability between different chains, which I think is maybe the most interesting part for complementary currencies. Bitcoin also uses proof of work, which I don't think complementary currencies need, because so before I go into this, everybody's validating everything, but there's something missing. Even two valid transactions could be both valid, but incompatible. So only one of them can be accepted. And you have to order the transaction in some way. Usually you solve this problem by having a timestamping server that is centralized, and you send transaction to it, and it orders them as it receives them. Bitcoin, instead of that, is just proof of work, which is decentralized timestamping servers, and anybody can use their computers to mine. It's becoming a very specialized business, but this has advantages and disadvantages. It provides more decentralization. It makes Bitcoin extremely hard to shut down, like other peer-to-peer software. BitTorrent, maybe you know, the copyright cartel would love to destroy that, but they cannot because of how the technology works. And this is similar, but it also have disadvantages. Mining is very costly because it's burning energy, Um, and it also has some challenges for scalability, but on overall, it provides more resilience to Bitcoin. But you don't, local currencies don't have these strong requirements of not being completely very hard to shut down by governments or things like that, or being global. That its requirements local currencies or even business-to-business currencies don't have. So you can replace proof of work with, for example, signed blocks. And that's what we're doing in Elements project, which is it's based on Bitcoin Core. Bitcoin Core is the main or the reference implementation for Bitcoin, but there's more. So we reused that software, changed some things so that it can be used for other things that are not Bitcoin. And you get many of the advantages: auditability, extensibility, interoperability. But you don't need to get the disadvantages from proof of work, because you don't need the advantage either. So in Elements, we replaced proof of work with signed blocks. And we also had added some new features that maybe are somewhat controversial for Bitcoin or not so useful for it, but can be useful for other systems. Like confidential transactions could be useful for Bitcoin, but since it has some cost, it's probably controversial in that way. Multiple assets is more controversial, so. But for complementary currencies can be very useful. So the goal of the project is that you can reuse this software to create your own chain for your own purposes. So as I was saying, we're replacing proof of work with more concretely with scripts. The same scripts that we use for the transactions can be used now to sign the blocks. And that provides a lot of flexibility. For example, you can have a single signer, or you can use what we call multisig, which is several signers have to sign for the script to be valid, or maybe a threshold of them, for example, KFN. And that model we call a federated chain, because it's a federation of signers that create the new blocks that everybody validates. So it's less centralized, less decentralized, but it's probably good enough, I think, for complementary currencies. Another feature that I think it's very interesting for complementary currencies is the ability to issue new assets or new currencies, so that you can have several currencies in the same chain. That makes them very interoperable, because you can trade them directly in the chain or convert it if the administrators of each currency have some agreement to convert them at a specific rate or something. You can do all that in the chain. Bitcoin also has a fixed monetary base. So it will be a fixed amount. It's not fixed yet because more Bitcoins are being created, but it will end up in 21 million, and that's it. It will, well, apart from what people lose. With this, with custom assets you create, you can decide whether the asset is going to have a fixed quantity forever, like Bitcoin, or some authority can issue more or of the same. You can have special keys that allow you to create more quantities, which is necessary for some use cases with complementary currencies. For example, local, I don't know, mutual credit. You may need to issue more. It's flexible, so you may need not a fixed quantity, but a flexible quantity. And a little detail, you can hash a legal contract or a Ricardian contract, which is kind of a mix between a legal contract and a smart contract. And that can be associated to the asset, even though the chain doesn't do anything with it, but it's it's immutable. Anybody, you can prove anybody that that's the legal contract associated to it. Another disadvantage of Bitcoin is that it has pretty bad privacy. Some people think it's anonymous. It is not, absolutely not. It has indeed very bad privacy compared to other systems. So all the transactions are public, but your name doesn't appear in the chain. You're associated with your own keys. You have several. And supposedly that gives you privacy because with each payment you create a new one. But there's companies that analyze the chain, use data mining, and it turns out they can find out a lot of things, and they can associate all your keys, find out that you're the same person, even though they may not know who exactly you are, but maybe they find out some other way later. So that's bad. And yet, even that transparency doesn't protect you from harmful users that exploit this pseudonymity. Because let's say a thief that steals from an exchange or from anyone, he can become anonymous. It's not that it's impossible, it's that it's expensive and hard to do. And most users don't do it. And traditional system, both banks or complementary currencies, usually you know your balances. The banks know everyone's balances, but nobody else does. Right? That's what you expect normally for businesses. For businesses, is especially important because they don't want maybe the competition to know how much they're paying to their providers or how much they're selling something for, or a negotiation position can be undermined. And we can also discuss more philosophical things for personal use, like some people say, well, privacy, financial privacy is a requirement for free speech and things like that, but we won't enter into that. And at the same time, the public consensus need verification. So it's like contradictory requirements, but surprisingly, it's possible to do both. And if you think of digital signatures, it's very similar because it's somewhat magic in that same sense that nobody knows your secret key, but you prove that you know it by signing whatever messages. So we develop a feature which provides this. The amounts are hidden, the assets IDs are hidden, but you can share the secret with an auditor, maybe the RRS or whoever, and they can validate and they can know the amounts. But everybody else, without knowing the amounts, they are still able to validate that nobody is creating any money, that they're not changing one asset for another in a way that they shouldn't. So it's kind of magical to me. I mean, it's cryptography that I don't fully understand. The security of this system is we have computational security for not creating inflation. That's good. That's what the digital signatures have as security as well. That means maybe nobody, to break this, you need the whole computing power of the whole world for 100 years or something, but it's not perfect. Informational security, it's better. That's impossible to break, mathematically impossible. And we have that for the privacy, but not for the inflation. We're working on. We know you cannot have informational security for both at the same time, so we're working on trying to have the best security on the other side, on the not inflation, not creation of money. So, and the privacy, okay, it's important, but not as much as the other part. Another feature, it's payment channels. Payment channels are a smart contract that accumulate several payments without publishing in the chain. You sign, you pay one, let's say you buy bread one day another day, and at the end of the week you accumulate 7, and then you publish that instead of publishing every time. That way you can pay less fees, you gain privacy because you publish less things in the chain. It also improves the scalability because there's less things in the chain, and it provides instant payments, which aren't really instant because they aren't in the chain yet. But like it's the customer to defraud you would have to. So it cannot defraud you because you have a month to publish it or something like that. It's secure in that way, and Lightning is. Connected these payment channels so that instead of being only one person to one person, you connect them, and through several of them you can reach someone you don't have a direct channel with. It's like a network. And this, surprisingly again, without almost any change, where now it's been developed only for Bitcoin, but with much more work, you can use it for multiple chains and multiple currencies, which perfectly solves the intertrade problem between currencies. And now I'm gonna go fast through this because I spoke too much already. So this is one example. You could use a single chain for your single currency. And you could have several signer servers only for more reliance and more security. Let's say you have 3 servers and 2 of them have to sign for a block to be valid. And you get all many of the other goodies of blockchains. More interesting would be several communities joining in the same chain. Each have their own currency, but they're all signed the blocks. So they all valid. They cannot be defrauded, even if they don't fully trust the other administrators of the currencies. It can work. Take into account that we're also using this commercially for companies that are competitors between them, and it works. We did a demo with Digital Garage, which is a Japanese company, for doing exactly this for loyalty points, but it's the same for local currencies. So you can pay with a currency, with the currency you have in a place where they don't accept that currency. And you can also do the same with more chains and interconnect between them with Lightning and some other technologies I don't have time to talk about. And they can also integrate with Bitcoin and Ethereum and other things. Here's more videos. I guess this will get uploaded somewhere. So these are more technical, but if you want to check them out, and more links and questions. Well, I don't think anybody is using our system for complementary currencies yet. Digital Garage is working on it, but it's still research. And they talk about regional currencies in their webpage, but the engineers didn't know much about that. When we were working with the other engineers, I talked to them about local currencies in Japan, because I knew there were many there, and sometimes they were surprised. For example, they didn't know the Furiao Kipu, or but it was interesting to them, and I think on the business side on the company they're considering these two, but nobody is using it yet that I know.
I'm gonna play the bad academic here. I think you should be just a little bit more careful in the way you talk about it, to call it the first peer-to-peer currency, perhaps the first peer-to-peer electronic currency, but knowing about the history and the evolution of money, the osterkon, which were shards of pottery used throughout the Middle East with inscriptions, wampum among the North American Indians.
That's very...
There's many forms of kind of IOU currencies.
Yeah, I should have said the first peer-to-peer digital currency, exactly.
Anyone else?
My question is about how the manage how local complementary currencies should be created. I mean, in case of Bitcoin, of course, it's created by way of the process called mining. And do you think that the very process of mining is appropriate for complementary currencies, or for instance, it's also not like a no?
I don't think it's appropriate. No, I think you should issue the units however you did it before. You don't need to change the design of your currency. You can use the technology, and if it should fit you. If it doesn't fit you, it's not the problem of your design. I think it's the problem of the technology that needs to be improved to fit your design. So and this part about native ICD issuance, I said this, that you can reissue because many systems need this, and they issue based on their own rules, mutual credit or some other rules.
Is it free? Is it free? Is it free to download and use and experiment with?
It's not only free as in gratis, but free software as in freedom. Which is more important, I think.
And then the sort of link on, it's obviously, you said it's nothing to do with sort of mining, but the sort of multi-sig system, do you need to run something to keep it ticking over so the transactions are taking place and there's computers signing the transactions off? Or?
So technically, your wallet as a user signs the transactions with your keys. And then everybody that validates the whole chain, including the signers have to validate it for sure. The users can validate it or not, depending on what they want.
Thank you for the presentation, Jorge. I didn't know the system, and I don't have any insight in the technicalities. I will not tell you that any other blockchain approach is better or worse. Mm-hmm. You know, the battle is now quite fierce. But nevertheless, I'm an old guy in the telecom sector, and we have something that is called network externalities, which is the economy of the scale. That means that the more people use something, the cheaper it becomes, and so on. Now,
well, in these days, unfortunately...
No, wait a minute.
So, okay.
Network externalities, I would like that you clarify us a bit. In the old times, for example, the first protocol for email was quite inefficient, which was POP, and then companies developed much better protocols for that. In my personal life, I was about to be fired from Telefonica because Telefonica had invested in another protocol much better than POP, but nobody wanted that. What was popular, becoming popular, was at that time POP. Now, the question is, could you explain a bit more the market base or the supporting base? How many developers are developing around that? How many experts? How many interfaces? A bit this part of being excellent technically, but gaining a lot of support, and we expect it explodes to millions.
The Elements project itself, right now it's mostly us, our company, but we expect other companies and other communities to collaborate with us, test it, file bugs, issues, ask for new features, and implement them. I also collaborate, contribute with code. That's our goal. But take into account that these changes we do on top of Bitcoin, we allow on top of the newest version of Bitcoin Core every time, And this is Bitcoin Core is the project, without doubt, with more contributors, with more programmers and experts, I think.
So my question, two things really, about resource usage. So because you're not using mining and just digital signatures, does it work effectively for on embedded device, let's say Raspberry Pi and so forth, if you're a community and you run one, can you effectively digitally sign blocks that way?
Well,
sorry. And secondly, so the first one is, can communities run full nodes effectively on embedded devices like Raspberry Pis? And the second question is compatibility with the Bitcoin app ecosystem, mobile wallets, these sorts of things, APIs, how compatible are we?
Okay, I'm gonna answer the second first. So the second is about the API. Bitcoin Core's API have an RPC interface, and we have the same interface, only modified. We add some new things that we need for the multi-assets, for example, or for block signing. But on some of them we need to modify, but most of them are just like in Bitcoin. So that's pretty compatible with other software that it's based on Bitcoin Core. You can adapt this software to be compatible with Elements. And in fact, we have done with several libraries. And the first question was about running it in embedded devices. This first depends on the scale. Because if you have many transactions, maybe validating everything becomes cumbersome. But Bitcoin itself, you can now validate it in a device, in an embedded device, in a Raspberry Pi. But you may not be able to store the full chain. You download it once, validate it, and then remove the parts you don't need. And in Bitcoin, we're working on more scalability improvements so that small devices can do more, also to increase the scale, because many people are demanding more scale, and I think to increase the size limit, we should improve the scalability first, and we're doing it. So yeah, it is possible.
Okay, thank you for your presentation. I'm coming from Japan, so as far as I know, there are already 3 examples of integrating the blockchain and community currencies. And I would like to ask you, what's the merit and demerit of this kind of community currencies? Because I know they are using the blockchain for local banks, networks, and also, the community currencies in the local area, but by the natures, it's not local. It's all over on the internet. Mm-hmm. So, do you find any difference between this kind of blockchain type of community currencies and, say, cyclos on the internet?
Yeah, I think both are technologies. Cyclos and these are suitable for complementary currencies. Cyclos is not suitable for peer-to-peer currencies. But I don't know the specific chain that you're mentioning in Japan. So maybe we can talk more about this later. I don't know.
Okay, thanks very much, Jorge.